In this chapter, we will look at the definition of angular velocity and then talk about the relationship of angular velocity of wheels to the linear velocity of a bicycle.
You may have a real curiosity, so I'll focus on bright luminosity and some terms interject as I try to connect linear and angular velocity. Most people have an intuitive understanding of what velocity means, but rotating objects have angular velocity also. This chapter will go into the specifics of linear and angular velocity, how they differ and how they're measured.
Here's a graph of a circle, but what I'm going to do is rotate the whole graph 90 degrees to the left so I get the 0 at the top. This is going to be the graphic that we'll use to study the wheel. Now, degrees are useful, but we have to get a handle on radian measure. Starting at the top, which is 0, 1 radian, 2 radians, 3 radians, 3.14 radians, which is pi, 4 radians, 5 radians, 6 radians, or 6.28 radians, which is 2 pi. In between, I have pi over 2 radians and 3 pi over 2 radians. 1 revolution per second will be 2 pi radians per second, and watch this. In 1 second, 2 pi radians. So that red dot shows the rotation of the wheel. Here it is again, 1 revolution in 1 second. 2 revolutions per second would be 4 pi radians per second and would look like this. And after all the time it took me to work at this graphic, let's look at it one more time. 3 revolutions per second would be 6 pi radians per second, and here we go. 3 revolutions. Here we see the wheel in its starting position, and we're going to roll it to the right. Ending with a red dot at the bottom, which is where it was 1 revolution ago. If my rim has a diameter of 630 millimeters, then the circumference is pi times the diameter, and that gives me 1.98 times 10 to the third millimeters. So as the wheel rolls from that point to that point, the distance transversed will be 1.98 times 10 to the third millimeters. Similarly, let's roll the wheel and the bike together over that distance. We have rolled out 1.98 times 10 to the third millimeters at the same time that we have seen 2 pi radians of rotation of the wheels. As a reminder, that rollout distance of 1.98 times 10 to the third millimeters is the circumference of the wheel with a tire on it, and that is the diameter times pi, which is 630 millimeters, times 3.14. The distance that the red dot travels per unit of time is equal to the distance that the bike travels per unit of time. The radius of the wheel in meters times the angular velocity in radians per second is equal to the velocity of the bike in meters per second. The term radians is a dimensionless number, but we usually use that in calculations just to keep track of the units. The Greek letter omega is used to represent angular velocity in radians per second. If the velocity of the bike is 1.98 times 10 to the third meters per second, then the wheels will roll 1.98 times 10 to the third meters per second. The radius of the wheel times the rotational velocity of the wheel in terms of radians per second is equal to the velocity of the bike in meters per second.